Okay, now moving on to the next presenter, Jerry Sun from JA Solar. Jerry is a senior manager of product promotion at JA Solar. I have to, yeah. So Jerry is going to talk about design concept and updated technical features of Deepblue 4.0 Pro based on 182 by 199 wafers from JA. I think it's really interesting. So I also know a little bit of background. So Jerry, I'm really looking forward to see your interesting insights into making different modules with one wafer size. Jerry, the floor is yours.
Okay. Can you see me?
Yes.
Okay.
See, and I can also hear.
Okay. I will share the screen. Wait a minute. Yeah. Hello everyone. Yes. This is Jerry from JA Solar. Today I want to share you a presentation about design concept and updated technical features of Deepblue 4.0 Pro based on 182 millimeters times 199 millimeters wafers. Okay, this presentation includes 3 parts. The first part, JA Solar product technology roadmap. As we all know, to a certain extent, the solar cell technology represents the technology of PV products. First of all, let's review the crystalline silicon solar cell mass production efficiency promotion roadmap. From this graph, we can see the mass production efficiency of crystalline silicon cell has increased from 18% to more than 23% in 10 years. Especially the P-type PERC cell was put into mass production in 2016. Up to now, as the PERC cell gradually reached the peak efficiency of industrialization, N-type cell has been put into mass production, and the cell mass production efficiency has been more than 24.5% or even higher. Next, let's look at the JA Solar cell efficiency roadmap. We can see the mass production efficiency of P-type persium and N-type bycium. The mass production efficiency of P-type persium and N-type bycium is 23.8% and 25.3% in 2023 H1, and will be 24% and 26% in 2025. Bycium Plus is based on TOPCon technology. From the current view for the N-type cell, with the process improvement and raw material optimization, the Bycium Plus cell efficiency improvement will accelerate. Of course, JA Solar will also continue to resolve and develop other cell technologies such as HJT, XBC, tandem-perovskite, and silicon. Okay, next, let's look at the JA Solar new generation N-type module, Deepblue 4.0 Pro. We call it Deepblue 4 Pro, the next introduction. This kind of module was released for the global market in May this year in SNEC PV exhibition. The second part, Deepblue 4 Pro module technical feature. We know for PV modules, The technical indicators that we are very concerned about are the power and the efficiency. The power of the 72 cell Deepblue 4.0 with 246 millimeters times 1134 millimeters can reach 630 watts, and the efficiency can exceed 22.5%. Solar cells are the core of the PV modules. bycium+ is an efficient n-type solar cell independently developed by GA Solar, which is based on low oxygen and high minority carrier lifetime n-type wafer, and adopts optimized passivation and contact technologies, super thin busbar, and two-sided anti-flexion film technology, and so on. The VOC of the cell can reach 725 milliwatts, and the efficiency can reach 25.3%. At the same time, Deepblue 4.0 integrates SMBB technology. For the SMBB technology and high-density encapsulation technology. For the SMBB technology, GA Solar adopts more than 16 busbar according to the module power and the welding reliability. Okay, next, let's talk about the design concept. One of the most important design concepts for Deepblue 4.0 modules is the use of more inclusive rectangular silicon wafer. So, why is the inclusion of silicon wafer mentioned here? As we all know, there are square silicon wafers and the rectangular silicon wafers on the market now, and rectangular silicon wafers also have different sizes, and silicon wafers of different sizes are combined into different sizes and different dimensions of modules. For example, from this date on this page, you can see different module layout with different module lines, thereby adopting different sizes of silicon wafers. We can see such as 182 times 182 times 186.8 times 210 times 183.75 times 185.3. In this case, it will cause certain troubles to the entire supply chain and customer applications, resulting in the increase of non-technical costs in the whole industry. And the industry has been developed aware of this. Based on this background, after repeated verification, GA Solar introduced 182 millimeters times 199 millimeters silicon wafers here, different from other rectangular wafer sizes. The 182 times 199 rectangular silicon wafers can use different cutting methods to maintain the module width of 1134 millimeters while satisfying 4 mainstream types of modules. From the figure, we can see when cutting symmetrically along the 199 millimeters direction of the silicon wafer, the 182 times 199 half-cell solution obtains a 72-cell module with a size of with a size of 246 times 1134 and the power up to 630 watts. When the silicon wafer is cut asymmetrically, the 182 times 210 based on you can see here, based on 105 millimeters half cell solutions, obtain 66 cell module with a size of 2382 times 1134, and the power can reach 610 watts. In addition, the 182 times 188 based on based on 94 millimeters half cell solutions obtains two module dimensions. The first one, the 72 cell module with a size of 2333 times 1134 and the power up to 595 watts. And the second one, the 54 cell module with a size of 1762 times 1134 and the power up to 450 watts. Okay, this product idea enables Deepblue 4.0 to adapt to the demands of different application scenarios, such as residential rooftop system, commercial and industrial rooftop system, and utility scale power plants. Okay, next page. Through the introduction of the module product solution based on 182 times 199 silicon wafer, I think you have a deeper understanding of the rectangular silicon wafer size, and the unification of silicon wafer size will bring higher value to the industrial chain, including strong equipment compatibility, uniform material specification, standard module size, lower integration cost, better system value. Similar to earlier generations of Deepblue, Deepblue 4.0 has excellent power generation capacity. Based on bycium+cell technology, Deepblue 4.0 has outstanding power generation performance, such as low degradation, better temperature coefficient, higher bifacial generation gain, and better low irradiance performance. Okay, we know reliability is the foundation, fundamental guarantee of the performance of PV modules. Deepblue 4.0 modules have passed all standard and enhanced reliability tests, and the test results meet the IEC standard test requirements. So far, Deepblue 4.0 modules have received many product certifications that recognized and verified its power generation performance, safety performance, and strong reliability in various application scenarios. Okay, the third part, let's talk about Deepblue 4.0 module value analysis. As the core indicator to measure the power generation of PV projects, LCOE is closely related to the core value focused on by the end customers. Module-related factors include module price, module efficiency, module power, module energy yield performance, and the long-term reliabilities. Specifically speaking, high power and high efficiency can reduce the BOS cost effectively, and the power generation capacity and the long-term reliability is conducive to the efficient and stable power generation of products in the full time circle. Okay, for the energy yield performance, GA Solar and the TV not operated 1 year field test. The results show that the energy yield of the N-type module based on bycium+cell is 3.9% higher than that of the P-type modules. The N-type module's theoretical power generation gain is about 4%, and this number is consistent with field test data and publicly available industry statistics. Next, I will introduce the comparative data of system calculation for different products. When compared with P-type modules in different application scenarios, project types, and the installation methods, the BOS cost and the LCOE of Deepblue 4.0 can be reduced by about 2% to 4.5% and 2.5% to 6% compared to the N-type module with original dimension. The BOS cost and the LCOE cost can be reduced by 1.4% to 2.8% and 0.7% to 1.6%. Similarly, we have calculated utility scale plants in different countries, different regions, different climate conditions, and different installation methods. Under the tracking system compared with the 550 watts P-type modules, the 630 watts Deepblue 4.0 module can reduce the BOS cost by about 4.8% to 6.4% and LCOE by about 5% to 6.5%. Compared with the 575 watts N-type module, Deepblue 4.0 module can reduce the BOS cost by about 3% to 4% and LCOE by about 1% to 1.8%. Okay, under the fixed mounting system compared with the P-type module, Deepblue 4.0 module can reduce the BOS cost by about 3% to 4.5% and LCOE by about 4.2% to 5.3%. Compared with the N-type module, Deepblue 4.0 module can reduce the BOS cost by about 1.5% to 2.5% and LCOE by about 0.4% to 1%. From the above system analysis, you can see the Deepblue 4.0 module has the better value, has a better customer value. Okay, finally, I'd like to introduce the module selection logic in brief. How does the customer choose the right module? in addition to the module price, power, efficiency, we should be very familiar with the technical features of the modules. Take the bifacial module performance as an example. 10% bifaciality here. 10% bifaciality difference can bring around 0.5% to 0.9% power generation gain in low latitude region, and around 1% to 1.6% power generation gain in high latitude region. In addition, the temperature coefficient of power as the key indicator of different technologies and different products. 0.05% per degree Celsius temperature difference can bring around 0.5% to 1.3% power generation gain in different temperature regions. So therefore, for customers, it is necessary to comprehensively consider and choose the PV modules with the best LCOE. GE Solar will continue to provide high quality, high efficiency, and low cost PV products for the industry. Okay, that's all I would like to present. Thank you for your listening. Thank you.
Okay, Jerry, thanks a lot. I think this is really very interesting that you are able to make 3 different modules with different cell sizes from one wafer format. It's really, I think you also triggered a lot of interest in the chat room. But I have one question from my side. You have this 630 watt 72 cell modules, which is 2465 by 1134, and then you also have 610 watt 66 cell modules, which is 2384 by 1134. So both should be suitable for the large ground projects, right? So then how to really choose between these two, and the power difference is not so high?
Okay. 630 watt 72 cell module with 246 FL times 1134 is the core product of Deepblue 4 Pro series for utility scale power plant. This module size is, this module size is the same as the 182 series 78 cell module size, which is a standard module size, and this size has been fully verified by the market. For this module, the customer can get lower BOS cost and LCOE. The other module, 610 watts with 2384 times 1134. This module has the highest container utilization rate, also has higher power. So this module can be used in the utility scale, also used in the Chinese C&I plant. Okay, so for these 2 kinds of modules, you should comprehensively evaluate transportation cost, BOS cost, and choose the best LCOE products. Okay. Sorry.
Oh, sorry, I'm muted. Sorry, but I would like to ask one more question. So, how high density encapsulant differ from standard available encapsulant? So, can you throw some light on that?
Okay, high density encapsulation. We use the small gap between cell and cell. This technology, we think we balance the reliability, balance the production, and can enhance the module power. Yeah.
Jerry, there are really a lot of questions in the chat window. It would be really great if you can stay and answer these questions.
Okay, thank you.